Chemical reaction. A chemical reaction is the process of breaking of chemical bonds in one or more substances and the reforming of new bonds to create new substances. So when you make pizza, which changes are physical and which are chemical changes? So, a physical change that take place when making pizza is when the cheese melts because a new substance is not created. Another physical change is the pizza increasing in size while it cooks. So, the process of making pizza involves some physical changes like chopping vegetables. The process used by yeast in the dough or by the gas stove to bake the pizza are chemical changes. Here's the substances that change. Methane is a gas plus oxygen is the gas. Substances that are formed. Carbon dioxide is a gas. Water is a liquid.
Evidence of chemical change. There are four indicators of chemical change are formation of new gas, formation of new solid, release of energy, heat or light, and the last is color change. Chemical reactions. Substances that change and has methane gas plus oxygen gas and has substances that are formed carbon dioxide gas plus water gas. And this is the formation, and the fourth formation is the bubbling, turns cloudy, color change, and temperature change. This bubbling is a new gas is forming, and turns cloudy is a new solid is forming, and color change, a new substance is forming, and lastly is the temperature change has energy is released or absorbed. And this is the chemical reaction that are formed and change. Reactants and products. In chemical reaction, you start with reactants that are combined to make products. The reactants are the starting substances. The products are the new substances which result from the chemical reactions. Reactions and products. In the reaction, methane, a natural gas, is burned and combusted. Some energy is added to get the reaction started. These reactants, energy added to start the reactions. And this second picture is bonds that broken and be a form of new bonds form, energy released. And this products is forming and energy has released. Reaction symbols. These symbols has a meaning and these four is stands with S, substance is a solid, and L, substance is a liquid, G, substance is a gas, and AQ, substance is dissolved in solution or aqueous. This small symbols is a parenthesis. Next to each chemical formula indicate the phase of each substance in the reaction. And this solid, gas, liquid, and solution, this is the small symbols.
The law of conservation of mass states that in a chemical reaction, mass is neither created nor destroyed. For example, the carbon atom in coal becomes carbon dioxide when it is burned. The carbon atom changes from a solid structure to a gas, but its mass does not change. According to Antoine Laurent Lavoisier, a French chemist, established an important principle based on his experiments with chemical reactions. The combined mass of the burning wood and oxygen is converted into carbon dioxide and water. Burning wood is an example of a chemical reaction in which wood, in the presence of heat and oxygen, is transformed into carbon dioxide, water vapor, and ash. Conservation of mass. Lavoisier showed that a closed system must be used when studying chemical reactions. When chemicals are reacted in a closed container, you can show that the mass before and after reaction is the same.
How are reaction written?
When a chemical reaction is written using chemical formulas and symbols, it is called a chemical equation. Hydrocarbon plus oxygen to carbon dioxide plus water. Methane gas reacts with oxygen gas to produce carbon dioxide gas and water vapor. Numbers in equation. Water molecule HO2. H and O is element symbol. 2, 2 is subscript means there are two atoms. No subscript means there is one atom. Chemical equation, and an arrow is always included between reactants and products. It, it means to produce or to yield. Reactants to produce products. So, methane combines with oxygen gas to produce carbon dioxide gas and water vapor.
Balancing equation is a chemical equation in which mass is conserved and there are equal numbers of atoms of each element on both sides of the equation. The law conservation of mass is applied by balancing the number and type of atoms on either side of the equation. Type of atom on methane reaction. There is a carbon, hydrogen, and oxygen, and a total of reactant side. This side of carbon is 1, and the total product of side is also 1. And the question is, there is a balance? Yes. And hydrogen, a total of reactant side is 4. Total of product side is 2 times 2 equals 4. There is a balance? Yes. And there is oxygen. And the total reactant side is 2 times 2 equals 4. Total on product side is 2 plus 1 times 2 equals 4. And there is a balance? Yes. Counting atoms is necessary to balance an equation. There is 1 reactant of carbon and to 1 products of carbon, 4 reactants of hydrogen to 2 products of hydrogen, 2 reactants of oxygen to 3 products of oxygen. Balancing chemical equations. A balanced chemical equations have the same number of each type of atom on the product side and the reactant side. To balance the equation, we add another water molecule to the product side and add another oxygen molecule to the reactant side. We can practice balancing equations using CPO periodic table tiles and pencils and paper. Solving problems. In this reaction, chalcocite, a mineral, reacts with oxygen in the presence of heat. The products are a type of copper oxide and sulfur dioxide. Balance this equation. 2 copper atoms sulfur plus 3 oxygen to 2 copper oxygen plus 2 sulfur. 1. Looking for the coefficient for each molecule. 2. Given chemical formulas which shows type and number of atoms. Type of atom. There are copper, sulfur, and oxygen. The reactants of copper side is 2, and the product side is 2. Is there is a balance? Yes. And there are sulfur. The reactant side is 1, the product side is 1, and is there is a balance? Yes. And oxygen. The reactant side is 2, the product side is 3. Is there is a balance? Yes. Number 3. Relationships. Coefficients can be added in front of any chemical formula and chemical equation. When a coefficient is added in front of a chemical formula, all atoms that are formula are multiplied by that number. Use common denominators to help choose coefficient to try. 4. Solution, trial and error. 2 copper atoms sulfur plus 3 oxygen to 2 copper oxygen plus 2 sulfur. Atoms. There are copper, sulfur, oxygen, and the reactant side of copper is 2 times 2 equals 4, and the product side is 2 times 2 equals 4. Sulfur. The reactant side is 1 times 2 equals 2, and the product side is 1 times 2 equals 2. And oxygen. The reactant side is 2 times 3 equals 6, and the product side is 1 times 2 plus 2 times 2 equals 6.
Synthesis reactions. In a synthesis reaction, two or more substances combine to form a new compound, just like, for example, three oxygen atoms and two iron atoms will result ferric oxide. In synthesis reaction, we need to balance the atoms of each element, just like what is shown here.
The process of creating large molecules from a small one is called polymerization. The common polymers are polystyrene, polyethylene, polyester, polyvinyl chloride, and polyvinyl acetate. So we have the polymer products, foam containers, food packaging, clothing, plumbing or PVC pipe, and chewing gum.
AB is the single compound, and the left side is a compound broken down into simple component which is the A plus B. Mercury oxonium sulfate or 2HGOS. If we are going to decompose it, it will become 2HG1 plus O2 gas. This is decomposition and electrolysis reaction. 2H2O equals 2H2 plus O2, and this is the synthesis and combustion and oxidation reaction. 2H2 plus O2 equals 2H2O.
This composition reaction occurs when one reactant breaks down into two or more products. It can be represented by general equation A plus B equals AB. In this equation, AB represents the reactant that began the reaction, and the A and B represents the product of the reaction.
Oxygen gas, oxygen bubbles, positively charged metal. Hydrogen gas, hydrogen bubbles, negatively charged metal. Water with dissolved salt. The salt allows electric current to flow in the water. External source, energy source.
Single displacement reaction. In a single displacement reaction, one element replaces a similar element in a compound.
A reacts with X plus B. So A is a single element and reacts with the compound X plus B. A pair either X or B. If it's paired with X, it's going to kick B out of the solution. So now B is a single element by itself. And AX is a compound. So that's the general form of single displacement reaction. So what are the example of this? Let's say we have iron metal reacted to a solution of copper chloride, which gonna be instant. Iron metal is going to replace the copper metal in the solution. Ion trade place with copper. So copper is in the solid metallic form and iron chloride dissolved in the solution.
Double displacement reaction is an exchange or metathesis reaction occur when two parts of a unique compound are exchanged, making two new compounds. Examples: AB plus CD will become AC plus BD. Another example is lead quantity nitrite ion sub 2 plus 2 potassium. It will become lead sub 2 iodide plus 2 potassium nitrite.
Double displacement reactions. The picture shows solution A, the precipitate, and the solution B. A precipitate is a new solid product that comes out of solution in a chemical reaction. The formation of the cloudy precipitate is evidence that a double displacement reaction has occurred.
so fair.